Now let's talk about the most important front, that's called cold front. So normally if we would like to wrap up the discussion of the cold front in 1 minute, we would say when two air mass, one is cold air, another one is warm air. When cold air invade into the warm air and cold air push warm air up, and the boundary line there is a front created, it's called cold front. And in brief, the nature of cold front would be something that cold front slope would be steeper. Cold air is denser and heavier than the warm air, so we see at the front which is steeper, sharp, so we will also see the sharp changes in temperature, air pressure, and also wind. That's why we would have a hazardous situation, causes heavy precipitation, and also we can see violent thunderstorm. But we will discuss about the cold front in depth now. The cold front, if we are looking at this slide, the cold front between point B and point C on the surface weather map, it represents a zone where cold and dry stable polar air is replacing warm, moist, and conditionally unstable subtropical air. The front is drawn as a solid blue line with the triangle along the front showing its direction of movement. How did the meteorologist know to draw the front at that location? A closer look at the front will give us that answer. The weather in the immediate vicinity of this cold front in the southern United States, as it is shown in over here, the left side of the slide, the data plotted on the map represent the current weather at selected city. The station model used to represent the data at each reporting station is a simplified one that shows temperature, dew point temperature, present weather, cloud cover, sea level pressure, and also wind direction and wind speed. So the little line in the lower right hand corner of the each station shows the pressure tendency. The pressure changes, whether it is rising or falling during the last 3 hours. So we have the understanding or familiarities of the station model by now. So with all this information, the front can be properly located. We can use the following criteria to locate a front on a surface weather map. That would be sharp temperature changes over a relatively short distance. Changes in the air moisture content would be as definitely as shown by the marked changes in the dew point. Shifts in the wind direction we can see. And also we can see the pressure and pressure changes. Cloud and precipitation pattern. Well, if we are exactly still looking at this picture, the left side, we can see a large contrast or differences in air temperature and dew point temperature on the either side of the front. There is also a wind shift from southwesterly ahead of the front to northwesterly behind it. So if you look at, you can notice that each of the isobar links as it crosses the fronts, forming an elongated area of low pressure, and we call it trough, which is account for the wind shift. because surface wind normally blow across the isobар towards lower pressure. We find wind with a southerly component ahead of the front and wind with a westerly component behind it. Since the cold front is a trough of low pressure, sharp changes in pressure can be significant in locating the front positions. One most important fact to remember that the lowest pressure usually occurs just as the front passes a station. So if you are looking, you can find out that. If we move towards the front, the pressure drops, and you move away from it, the pressure rises. This is clearly shown by the pressure tendency for each station on the map just before the front passes. The pressure tendency shows the atmospheric pressure is falling while just behind the front. The atmospheric pressure is now begin to rise, and then further behind the front the pressure is rising steadily again. So if you are right now looking at the right side of the image, that's we call Doppler radar image, precipitation image. The precipitation pattern along the cold front, the region is colored extending from northeast to southeast represent precipitation along a cold front. If you look very closely, you can notice that the light to moderate rain, which is colored in green, occur over a wide area along the front, while the heavier precipitation, if you're looking yellow, is found in a very narrow band along the front itself. So a strong thunderstorm is mentioned here as red in a certain area along this front. Okay, now the cloud and precipitation pattern, if we just saw that. If we look in this picture, at the front, the cold, denser air wedges under the warm air, forcing the warm air upward, much like snow shovel force snow upward as shovel glide through the snow. As the moist, conditionally unstable air rises, it condenses into a series of cloud form. So, with the slow moving cloud front, cloud and precipitation usually cover a broad area behind the front. When the ascending warm air is stable, stratiform clouds such as nimbostratus become the prominent cloud types, and even fog may develop in the rainy area. Occasionally, out ahead of a fast moving front, a line of active shower and also thunderstorm, we call this line is squill line. The squill line may develop parallel to, often ahead of, advancing front, producing a lot of precipitation and a strong gusty wind. So as the temperature differences across the front reduces, the front will often weakens and it will dissipate. Such a condition is known as frontolysis. On the other hand, if the temperature differences increases or temperature contrast increases across a front, can cause it to strengthen and regenerate into more rigorous or vigorous frontal system. This condition we will call frontogenesis. Okay, if we are looking over here, says that the regeneration front is shown again here. The front is weak, indicated by the low cloud gray tone along the front. As the front moves offshore over the warm Gulf Stream, it intensified into a more vigorous frontal system. So, we so far have learned that the bottom line of the cold front is, if we go back to the first slide, it would be saying that the cold front will be steeper, and it would be rainy, rainfall, thunderstorm, many things can produce from the cold front. And also we have temperature and pressure differences along the cold front.